And we are live. Welcome to Groundwater Talk Live for November 4th, 2021. I think we got a good show for you today. I'm Tballard, the groundwater guy, and let's dive in here. Everything seems to be working here. If you're present on either YouTube or on LinkedIn, please put something in the chat. We'll select some people later for our combo BART test giveaway, and I'll look forward to that. So our talk today is what we're really going to discuss today is really a simple and relatively inexpensive method for measuring biological activity in your water wells, and I can tell you that biomass and biofouling and biological activity in your well really contributes to about 80% of plugging cases in water wells in the U.S. and really throughout the world. So it's really an important issue. And the question is we can go to a lab and we use some really good ones and speciate the bacteria. We can look at our total bacteria counts. We can look at our anaerobic bacteria and a lot of different things that we normally do through our well health check process. But there are some simple ways out there to really look at the biological activity in your well. And one of these is the biological activity reaction test, also known as BART for short, because that is a mouthful. And that's what we're going to talk about today. And it's so simple. You can just do it in your office. It doesn't require anything special. It takes about 8 days to run the test, but no special conditions or anything. And just put some well water in and watch it, and you're good to go. So, but before we start talking about the BART test, let's really look at what some of the common signs of water well microbial problems are, and there's a whole host of them, but these are some indicators that you have bacterial issues going on in your well. And when we talk about microbes, microbial actions, we're talking about bacteria in your well, and the bacteria are everywhere in your groundwater. It's you're never going to get rid of the bacteria in the well, and so they're going to kind of keep creeping in there. The problem is when the conditions in the well tend to be a little conducive to the growth of bacteria because you're changing the chemistry of the groundwater at that location. You're oxidizing a little bit by having the well in there, and so it's a conducive environment for bacteria to grow. So when bacteria get to a certain point, they can become problematic, and we see some indications of that. Colored or cloudy water is usually one indication of bacterial activity going on in your well. Losses in production generally are indicative of plugging going on in the well. So you start to see reduction in your specific capacity that we've talked about in other talks, or losses in production. And there's generally some plugging going on. And like I say, in 80% of cases, there's going to be at least some bio component to that. Falling water levels when pumping, so greater drawdowns, meaning is not as much water is flowing freely into your well, so your well efficiency is down, so your drawdowns are going to get greater, and you're going to see that over time as your wells plug up. And once again, that's going to be indicated by your specific capacities as well, but that's an indication you got plugging going on. Erratic increases in iron. One of the most common bacterial or biofouling issues in a well is iron-related bacteria, and they're generally going to increase the amount of iron floating around in your well, and that's back to the first point here is you're going to see some colored or orange water and higher levels of iron in your well. So that's another common sign. When you get into using the BART test and you monitor these things over time regularly with the BART test, then you're going to see increased aggressivity, or aggressiveness, I guess would be a better way to put that, of iron-related bacteria, sulfur-related bacteria, and or slime forming bacteria. And these are the three categories that generally are our biggest problem causers when it comes to biofouling in the well. So those are the ones we monitor most frequently. We'll get into all the different BART tests for these things as well, but those are kind of your three biofouling problematic types of bacteria, and the increased levels of those bacteria in your well and aggressiveness indicates you got microbial problems and some fouling going on there. And lastly, occurrence of taste and odor problems. That's going to go with point number 1, 2. You got cloudy water, you have a heavy bacterial load, and you're going to start seeing some taste and odor issues. If you have sulfur-reducing bacteria, of course, you're going to get hydrogen sulfide and kind of that rotten egg odor going on, but just some other bad taste and can be indicative of a high bacterial load in your well, and that's not good, because now when you get a high bacterial load in your well, you can start getting some issues with pathogens creeping in there, conditions turning anaerobic, and some bad actors coming in there. So it's important to monitor these things and over time and properly assess them, and then clean out your well when you get to that point. Okay, so kind of the problems with biological activity in a well fall into two areas that we really need to address. And one of those is probably the top one everybody thinks about is biofouling. And we'll talk about that a little bit more in a bit, but that's your plugging that's going on. But the second one that most people don't really think about a lot is microbial induced corrosion, or MIC for short. But you look at things like sulfur-related bacteria, that's producing hydrogen sulfide gas that actually is corrosive to your well. But you're also looking at situations where you have other types of bacteria, other groups of bacteria that can create acids from organic acids or organic acids in your well, and other types of acids from organics in the well. And those can cause generally a lowering of pH in the well, and can create situations where the metal gets more brittle and subject to breakage and some damage there. So that's another corrosion issue. There's a couple types going on there, and something that you really want to look at, and probably not something that most people think of when they first think of biological activity in the well, because they're usually thinking of the plugging that's going on from the biofouling, and certainly that is an important issue. And speaking of the biofouling, really, this is the plugging that's going on, and people think about the slimes, which is, but there's really three components to biofouling in the well, and the first one is the slimes that everybody think of, and that's a slimy coating you get with biological activity. Now, that slimy coating is not really the bacteria itself. It's a protective coating that is actually produced by the bacteria that protects the bacteria. So the bacteria grow in and underneath this protective coating, and it really protects them. And this is why things like going in and doing superchlorination in a well that has a biofouling issue really is not the most productive way to deal with it. And obviously today we're not really talking about well rehab, but just know that there are better methods out there, and that the slime coating is really what protects the bacteria, and why superchlorination is not the recommended technique for cleaning bacteria out of the well, especially if there's heavy infestations in the well. But some other components of the biofouling are, as you develop this biomass in the slime, now you'll start to see accumulates, for want of a better word, mixed in with the slime, and that can consist of organics, nutrients, metallic cations within the slime, and this is really the bacteria catching their food sources there, and some of it is actually waste from the bacteria as well. So that's all kind of mixed in with the slime. And then the third one that probably not a lot of people really associate with biological activity is the mineral deposits. So a lot of these things like the iron and manganese nodules you see in the well are actually iron and manganese oxides that in a lot of cases can be precipitated out by the bacteria in the well through basically through them ingesting some of the nutrients that are in the water, and they will produce these iron and manganese oxides and calcium carbonates in some cases as waste products. So probably more of the iron and manganese oxides are what you'd see, but most people think those are inorganic deposits and they really don't have a biological component, but in a lot of cases they really do. So these are the three components of biofouling. Like I say, the slimes are what people normally associate with biofouling, but there's some other stuff going on here too. It ends up being a very complex system, and we're going to actually do a deeper dive in this in a future class we have coming up on biofouling in a well, where we're going to talk about the causes and diagnostics and basically some of the rehabilitation techniques. So look for an upcoming class on that, and we'll do a deeper dive on that. This is just a quick introduction here to get us to the topic of the day is the BART test. Okay, when it comes to microbial induced corrosion, or MIC for short, corrosion is really more common under reductive conditions, which some people would say anaerobic or reducing conditions. You'll hear it called different things, where sulfates are present, and that's your sulfur related bacteria, and they're going to generate hydrogen sulfide gas, which can be very corrosive. But when you have organics present, you have certain groups of bacteria out there that will actually generate acids from the organics as well. And that's what I talked about a little bit earlier is these can create situations where it can damage your well. It's not quite as aggressive as the hydrogen sulfide, but certainly can create damage in the well. A lot of people don't recognize that. Everybody knows about the sulfur-related bacteria and the rotten egg odor and the hydrogen sulfide, but most people don't think about these other classes of bacteria that can actually generate acids that can damage the well too. So once again, kind of a complicated situation when it comes to the biofouling and biological activity in your well. Also, under oxidative conditions or oxidizing or aerobic conditions, you can get sulfide, and sulfur can be oxidized to sulfuric acid, which can also be corrosive in your well. Sulfuric acid can certainly damage your well, and that's corrosive, and certainly it's a pretty strong acid. Most of these bacteria don't produce a lot of it, but enough to lower the pH, creates less than ideal conditions in your well. So these are really the two problems, is the biofouling and the microbial induced corrosion that we want to look at. And so that's where our BART tests come in, is really looking at classifying the types of bacteria and how aggressive they are in your well, the level of the bacteria in your well. So what's a BART test? Once again, BART stands for Biological Activity Reaction Test, and the technical definition is this is a semi-quantitative, which means you're not going to get a certified lab report. You're going to get some ranges, but it's fairly accurate and a good diagnostic for what's going on, especially if you track these things over time. So semi-quantitative tests that you can do on your desktop and are relatively cheap are great tools. Now, we would certainly recommend really once a year going in and doing a full assessment of breaking down the bacteria by the species and looking at some other components of the bacterial issues in your well. But these are things you can do on your desk, and like I say, they're not as accurate as a lab, but they work pretty darn well. And the trick here is to track the trends. You really want to see where things are going. Obviously, if you have really bad conditions in your well, you're going to need to take action right away. But overall, what you really want to do with these things is track trends. So we're recommending a suite of BART tests at least once a year. I would more prefer to go to semi-annual or even quarterly on these things. Like I say, they're cheap enough. These things run, if you buy them in bulk, get under $20 a test. So 25. The prices range around the place, and we'll talk later about where you can buy these things as well. So anyway, it's a semi-quantitative test that allows determination of the presence and aggressiveness. So both the presence of these types of bacteria and their aggressiveness. So how many are there, and how aggressively they're growing of certain bacteria in water wells, in well samples. So what we're going to do is the BARTs fall into certain classifications. So you're going to have they're going to break down into certain categories like sulfur-related bacteria, iron-related bacteria, and we're going to talk about that here just real quick. But you're looking at classes of bacteria, not the specific down to the species level. We're looking for certain types of things like iron-related bacteria. So, okay. So I do need to mention that BART testers are patented products. It's a registered trademark, and they're manufactured by Droicon Bioconcepts up in Regina, Saskatchewan, Canada. This is they're associated with Dr. Roy Collimore, who's really done a lot of pioneering work on doing diagnostics of bacterial activity in the well, and the originator of the BART tests. So we certainly want to give recognition to them, because a lot of the information I'm presenting here today comes from them, and it's such a great tool that we really want to recognize them for that. So just so you know. Okay, so this is where Droicon has really developed these tests over time. So you can see, really it goes back to 1986 when they first started working on their iron-related bacteria, or the IRB tests, and they started retailing that in 1989, kind of perfected it a little bit. Then they went on to develop probably the three main ones that I like to use. The iron-related bacteria, sulfate-reducing bacteria, and the slime-forming bacteria. These are really kind of the top three, and generally you can buy these together. It's called a combo BART, and get these tests there. But these have been retailed since 1989, 1990, and so they've been around, and so people in the know have used them, and they've developed some other ones. Some aren't specific to wells, like pool following bacteria. Obviously, they didn't make it on that. Sheath iron bacteria, they looked at a test for that. That would mainly be things like Gallionella, which is an iron-related bacteria, and some of these other things, they actually withdrew those. Fluorescent pseudomonids, that's still being marketed. There's limited sales on that, but that's specific to pseudomonids that fluoresce, and so you can dial in on those. Pseudomonids can be a pathogen, so that's one way to look at an anaerobic pathogen with that test. Another good test is the heterotrophic aerobic bacteria. That can really give you an indication of overall bacterial activity in your well, and so that would be certainly something you'd want to run on a regular basis. Cyanobacteria, probably more specialized case. Denitrifying bacteria, nitrifying bacteria, little bit more of a specialized cases. If you have nitrates in your well, you can certainly look at nitrifying bacteria. So that might be a BART test you'd want to run there, and they're working on one as of 2001. Anyway, I don't know if that's being marketed now. I haven't seen it on the market for biochemical oxygen man. And there's one more that's not on here. I don't know why it's not on this list, but acid-producing bacteria that produce the acids from organics in the well. So APB is actually another one that gets used. All right, so this shows actually the BART test, and This is for the iron-related bacteria, and you can see some of the color reactions you get. We'll dive into this a little bit more a little bit later, but you can see a variety of color reactions depending on the type and the aggressiveness of the bacteria. So there's some basic interpretation you can do, and there's a little bit more advanced interpretation. We'll look at that here in a little bit too. But these are the IRBs, and they're detecting iron-related bacteria. Sulfur-related bacteria. Hold on a minute. Let me turn off sound here so I don't get any feedback. Sulfur-related bacteria, more specific to sulfur-reducing bacteria, sulfate-reducing bacteria. And you can see some of the reactions there. You're getting more darker colors when you have positive results there. And Slimeformers, these are the types of bacteria that can create slime, turbidity, foul tastes, and odors. They're not generally sulfur-related bacteria or iron-related bacteria, but they can form prolific slimes that can plug your wells. So we really want to look at those too. So those are really the main three I look at: is the IRB, the SRB, and the slime BART tests. And then I mentioned this a little bit earlier, the APB test, organic production. These are, certainly if you have corrosion issues or the potential for corrosion issues in your well, you have organics that you detected, then you're probably going to want to run an APB BART as well to see if you have any of these acid-producing bacteria that can certainly damage your well over the long run. Okay, this is basically from a lab we've used that runs these things and runs some biological diagnostics, and this is what they call their simple well diagnostic panel. So they're looking at the IRBs, the SRBs, they're looking at the heterotrophic aerobic bacteria, so the HAB. They're looking at denitrifying bacteria here. I'd probably substitute in an APB or acid-producing bacteria test there. Fluorescing pseudomonids, I would consider that optional. We do see a fair amount of pseudomonas in wells, and like I say, it can be a pathogen. So if you're worried about that there's a BART test for that. And then certainly slime forming bacteria. So once again, the IRB, the SRB, and the slime are probably the major ones we'd run. I'd probably also throw in the HAB as well, and maybe the APB if you got concerns about that. Okay, so what do these things look like? Well, here we go. Here it is in a box. This is what it comes in. This is actually some I bought from Hawk, and sorry about that. That's the problem with live performance. You forget to turn off your cell phone. So here's what it comes in a box. So let's unbox this a little bit here. So you can see this is the IRB. They come here in foil. These are IRB BARTs. So they're coming in this foil wrap to protect them, and you do want to keep these out of the light. So the foil package here will actually keep it out of the light, and you can see there's the usual warnings and you're going to die and all that stuff. But the IRB there, and it's labeled properly, so you can see that. So as we open this up here, we grab it here, pull it out. Here is what the BART test looks like, actually. So you can see on the label here, it's got your little color code for the number of days. You may or may not be able to read that. It's a little fuzzy when you get it closer to the camera, but there's some instructions, and we'll go over these. These are printed on the bottle, so it's pretty simple to use. And really what it consists of is you have an inner tube and an outer tube here, and you have the little floating ball in there. You have your nutrients at the bottom here, and so this is basically going to simulate the situation that's going on in a well. So let's look at how we use this, and we'll kind of go along, follow along here. So the first thing you want to do is remove the inner tube from the outer tube. So this is taking the inner tube here out. And so here's now the inner tube. And so you're going to want to take that and have that handy. Next up, you're going to want to take the outer tube and you're going to collect at least 20 milliliters of well water in here. So you're going to take a sample from your well, put it in here, collect at least 20 milliliters, and that's going to be your sample that's going to go in the inner tube. So then what you're going to do is you're going to take the lid off here, and you're going to, there's going to be a fill line on there right here. So you're going to fill up to this fill line, and that's going to take probably about 15 milliliters at that fill line. So you're going to fill that up and set it down directly on a clean surface after you're done. And to avoid contamination, do not invert the cap. Leave the cap because you don't want any contamination going in there. You can contaminate these things. So you want to keep everything clean. You don't want to put your fingers inside here or anything like that. You definitely want to keep that clean. Okay, now once you got your water in there, you're going to tightly screw this lid back on. So you're going to put your water in it. I don't have any water here that I can do for this, but we're just going through things here anyway. And then you're going to put it back inside the other container, and you're going to put the lid on that too. So now you have your little laboratory set up here. And the thing you want to do in most cases, in most BART tests, you want to avoid shaking this. You don't want to shake it. You don't want to swirl it. You just want to put the water, let the water in there and let it do its thing. The nutrients at the bottom will dissolve over time. This little ball will release and it will float up. And you want to just let that happen naturally. You don't want to push that process along because you'll mess up the test that way. So you want to take care of that way and do not shake it. Now, there is one test, the HAB, where you do invert it and kind of stir it up that way, but most of the BART tests, you don't do that. So that's really important. All right, so the other thing you want to do is you want to take your pen or a marker and you want to mark the date, because that's important, because this is basically going to be an 8-day test. You're going to want to mark the date and the sample origin. So if you have well number 1, you just want to write well 1 on here and the date you started the test. So now you know how long it's been, just so there's no doubt. You know, sometimes we think we're going to remember and we don't. So it's always good. You know, was that 7 days? Was it 8? And that's going to be important in the interpretation. And then you're going to take your BART tube and you're going to put it on your desk where you can see it, or somewhere you can see it, and check it visually every day, or you know, if you're excited, you can check it every hour. You know, it's kind of one of those little toys on your desk to watch it change. You're going to want to keep it out of direct sunlight, obviously, so you don't want to have direct sunlight on it. So keep it out of the sunlight. Allow it to incubate at room temperature, and check it visually for reaction every day. So, okay. So now that we have that, these are the actually detailed instructions for interpretation on the IRB. The other BART tests will have similar type instructions, but the interpretation will be a little differently, and I'll show you some of the other ones here in just a minute. But this is basically what it's going to look like. So in the absence of IRBs, in this case negative or non-aggressive, the solution has no brown slime in it. So you just have a relatively clear solution there. There's no brown slime over time, and so you don't really have any IRB activity in that well. If you do have IRBs present, so it's positive, aggressive, you're going to have a brown slime ring or foam around the floating ball that's going to be at the top of the water, and or you're going to have a brown slime growth at the base of the tube. That's going to be indicative of iron-related bacteria in the well. You're going to want to watch this for 8 days. It's going to be an 8-day test. And if you really want to kind of get down to looking at the details, you can actually let it run for 10 days and see if you get any reactions. That'll indicate really low aggressiveness, and you're in good shape there. So you're gonna observe any growths or color changes, and check that against your cheat sheet that'll actually come with the BART, and then you're going to compare with the descriptions. Here's a little bit more advanced look. So right over here, we're looking at the BR, BG, and BC is really your iron-related bacteria reaction. So you're going to get brown rings, you're going to get a brown gel or brown clouds, and that's going to be indicative of iron-related bacteria in this well. If you have a little bit of discolored foam around the ball, that's going to be indicative of general anaerobic bacteria, if you're not seeing that anywhere else in the BART test. If you have a green cloudy solution, that's going to indicate you have Pseudomonads. Now, this isn't going to be as accurate as the actual Pseudomonad test, but it's going to give you some indication that you have Pseudomonads or Pseudomonas type bacteria going in there. Enteric bacteria is another type of bacteria that'll give you a red color. Heterotrophic bacteria or aerobic bacteria you're just going to have basically a cloudy solution. And then if you have a black solution, that's going to tell you have both Pseudomonads and enterics in your sample as well. So this is a little bit. You can actually do a little microbiology laboratory right there on your desk and really look at this and see what types of bacteria are growing in your well, and that's going to be important to understand, some of the issues in your well and certainly concerns you might have, and also the aggressiveness of things, what you're going to need to do to clean it up. So this gives you an indication of that. Okay, so over time, what we're going to see is these are number of days, and this equates to the concentration of bacteria in the well or the aggressiveness, at least in the sample. So these are measured actually in CFU per milliliter. CFU stands for colony forming units, and that's actually viable bacteria in there. So if you have if you get a reaction in 1 day, then you have a pretty aggressive and a high population of those bacteria in the well that's usually running about 570,000 CFU. That's awful high and probably something you're going to need to do something about pretty quickly. And you can see after 4 days, if you get a reaction after 4 days, you're down around 9,000. You're kind of in the yellow zone if you're seeing a reaction between 5 and 8 days. And if it's beyond 8 days, you can run this out to 10 days, for instance. You're just seeing low numbers, not very aggressive, and you're usually doing pretty well. So that's just for the IRB itself. Like I say, we can kind of dial in on what some of the other things are going on in the well just with the IRB test itself. But if you have some indications that you want to run BART tests for some of those more specific things. And this just shows you what this looks like for not only, we just went through the first one here, the iron-related bacteria, but sulfate-reducing bacteria, same type of thing. You're going to have, and I realize this is a little hard to read, but I'm just showing this up here for comparison purposes. And then on the right-hand side, slime-forming bacteria, you're going to have similar reactions as well, and a similar scale. Certainly, if you're getting the CFU per milliliter numbers are going to be a little bit differently depending on when you're getting your reactions. So you can see that 1 day on the SRB test is really going to be 2.2 million. That's a lot. That's really a lot. And on the Slimeformers, you can see the numbers there. And these are all CFU per per milliliter. So you can see, obviously, the quicker you get the reaction, the more aggressive, the more bacteria there are in the well, and the more urgency that you have to get that well cleaned out and do some rehab on that well. If you're in the green zone and even on the higher end of the yellow zone, then you got a little bit of time to operate on that. So, okay, so this is just looking at the SRBs, what this might look at. So we can see on the right-hand side here, your time lapse is that little chart that's printed right on the BART test kit tube, and it's your little cheat sheet there, and more detail. We just showed you that particular thing comes with the hold on a minute here. That particular cheat sheet that I showed you earlier comes with the test, so you have all the instructions you need. You can actually download that off the internet too, to have a PDF version, and that's helpful too. And you know, if you want to see what it looks like, you can just shoot me an email and I'll send you a copy of that as well. But you can see here on the right hand side we have a comparison test. The BART test on the left really has no SRBs in it. The BART test on the right is showing an SRB reaction, what that would look like, and it's generally going to be a little black reaction. So you can see you have some pretty strong. Now we don't know on this one how many days it took, but certainly you're definitely getting a reaction in that one. So up above we have our aerobic conditions. Down below we have our anaerobic conditions. Like I say, it's basically simulating conditions in your well, the zonation in your well, which is pretty cool, I think. Okay, that's basically it here. There are some, I showed you what you can do, just really basics on this stuff, testing your well water, and we would really run several of these tests. I'd certainly recommend the IRB, the SRB, and the Slimeformers to get a good indication. You can throw some of these other ones in there, and that's something you're definitely going to want to look at. There are some other things you can do there with these things, and you can actually build. You can take the BART test and actually build a 3D model of inside and outside the well, actually all the way back in the aquifer. You can take a number of BART tests over time while you're pumping the well, and each time interval is going to indicate that you're going deeper into the aquifer, and look and see where your highest levels of biological activity are happening. So if you don't have anything going on in your well, but you pump for say 24 hours and you're seeing higher levels outside the well, now you have that bacteria is there. It's going to actually start moving towards the well over time. So the growth is going to proceed towards the well, so you kind of know what's going on outside there. And if you really want to get fancy, if you have a lot of issues with bio in your well, you can even put packers in the well and build like a full 3D model of these things. That's generally not going to be something you're going to want to do, but it's just kind of showing you what you can do with these. With the BART test, beyond just checking and seeing what's going on in your well, you can check and see what's going on outside your well, and a lot of times that's going to be where your problem. Well, most of the time that's going to be where your problems originate, outside the well. So, and a well is a lot like an iceberg. What you see in your well, if you run a video down there, that's about 1/10 of what's going on, and 9/10 is going on in the screen and out in the gravel pack and outside the well. So you can get a look at that with the BART test too, getting a little innovative. So there's a lot of things you can do. I just kind of scratched the surface here, but I wanted to introduce you to this because it really is a great test and something we recommend everybody do, especially if you have any indications of biofouling in your well at all. Is there's a BART test for you, and you're going to want to run that at least annually, and I like to see them quarterly actually and track the trends, especially if you have issues with biofouling in your well. You're going to want to watch that and determine what your optimal time is for well rehab. Okay, where to buy these kits? There's several places online. I think there's probably more than this. I picked 3 here. Hawk, actually, everybody is probably familiar with them. I believe they actually produce their own under license from Droicon Bioconcepts, but I'm not quite sure on that. But I believe that is the case. The last time I bought BART tests from Hawk in the past, and they were pretty reasonable. But the most recent time I checked, their prices have really gone up. So they're really probably the more expensive option here. Lamont, everybody knows them from their turbidity meters. They are another place you can buy them, and probably one of our clients actually found this one, and this is really the least expensive I have seen. If you're buying in bulk, you got to buy in bulk from these guys. But Biotechnology Solutions is actually has some great prices on these things. Plus, they have a real cool video on their cover page of bacteria. So it's worth visiting their website just to check that out. So I like that. So okay, in closing, if you let me just check and see here if I got any comments. Not seeing any comments or questions. You can reach out to me at Tballard at groundwaterguy.com. My company is actually Southeast Hydrogeology, but this is an easy email for everybody to remember. So you can reach out to me if you got any more questions on this. I'm more than happy to dive into a little bit more detail. We kind of scratched the surface here, but this is a great tool, and I really wanted to recommend that everybody that's got a water well that maybe has any indication at all of biofouling, which is probably most wells, is going to benefit from this. Okay, so we are online. We go live every Thursday, 9 a.m. Pacific time, 11 Central, in the Groundwater Guy YouTube channel. This is the URL if you're interested in that, but you can just search for us on the Groundwater Guy YouTube channel. This is where I'm at on LinkedIn. I stream live into LinkedIn, so the videos are there as well. YouTube tends to organize them a little better, but if you're on LinkedIn, you can go to my profile and we stream right from there every Thursday. And we're happy to get you on and take your questions and answer and any comments that you may have during the live video. That's why we do it. So for you. And if you're interested in being a guest, if you're a water system operator or you provide services to the water industry that you think might benefit from reaching out to folks, we get the word out to folks. I have a Book Me page that you can log on and schedule a time. Like I say, we go live every Thursday, 9 a.m. Pacific time, 11 a.m. Central, and we'd be more than happy to have you on. You can just go to this link and schedule a date, and that'll schedule you in, and we'll chat a little bit ahead of time and come up with a series of questions. Normally we do like an interview format when we have guests on, but you can do a presentation if you want, and as long as we got some informative stuff that's going out to folks in the groundwater industry, that's what we're here for. So and lastly, if you're watching this on the replay, we really benefit from comments and shares, likes. Anytime you like, share, comment, it means we kind of get bumped up in the algorithm a little bit and get wider distribution, which is really what we're shooting for. We're trying to provide information to people in the groundwater industry, be they hydrogeologists like myself or vendors of some sort or water system operators. These are all people we're reaching out to with this information, and we're more so we try to get a wide distribution. So please feel free to post your comments, or just even a like and a share would greatly benefit us. Thank you very much. We are done for today, and I will look forward to seeing you next week, every Thursday on LinkedIn and YouTube, 9 a.m. Pacific, 11 a.m. Central. Signing off, the Groundwater Guy.